Welcome back. This lesson we're going to be talking about earthquakes and seismic waves and how to triangulate earthquakes and find the epicenter. All right, so with earthquakes, an earthquake is just essentially it's the violent shaking of the Earth's crust. Really, what it is this buildup of potential energy between two plate boundaries. And when any movement happens between those two plate boundaries, there's a release of energy, which releases seismic waves, which is the energy of an earthquake. And so that's just going to shake the crust. Two vocab words that I'm going to need you guys to know for the quiz and the unit post tests are focus and epicenter. So this is very important because they're kind of similar. The focus is the point under the Earth's surface where rocks break and under stress and cause the earthquake. So the focus is where the earthquake actually happens underneath of the surface. Okay, so right here is the focus. And then all of the energy from the focus gets released in all different directions, okay? It's not just one direction. It doesn't go straight up to the epicenter and then move over. This energy is moving outwardly in all different directions away from the focus. All right, now onto the epicenter. The epicenter is the point on the Earth's surface directly above the focus where we get this initial seismic reading. So the epicenter is directly above the focus, right where it hits the Earth's surface, okay? All right, so we've got some types of seismic waves. We went over this a little bit briefly in a previous lesson, but we'll go a little more in depth into it. So we've got P, or primary waves. Those are the fastest waves, and they have an accordion type of motion. So right here, what they're doing is they're just kind of like moving in and out like this, like an accordion. You know how it goes like that? That's the energy. So the particle motion is going this way, but the energy is it's going so fast and so powerfully that it's making this type of thing happen on the surface. Then we've got S waves, which are secondary waves, S or secondary. They're snake-like, and the important thing to know about them is they cannot travel through liquid. So here we get that snake-like motion here, up and down. And the important thing to know about with them not being able to travel through liquid is if we are in an area where there's been a seismic reading and we only get P wave activity, that means that there's some sort of liquid body that S wave traveled through. And so like I said before with our previous lesson, this is how we know that the inner core or the outer core is actually liquid, because those P waves can go through actually the whole Earth, and we can get one from one side of the Earth, a measurement of a P wave from one side of the Earth to the other directly, but we don't get any secondary wave measurements because it has to travel through that liquid. And then we've got surface waves, or L waves, and those do the most damage. They have this like cyclical type of energy. So what's happening is that energy, the particle motion is going this way, but it's creating this weird cyclical action in the surface because the surface ends up kind of acting like a fluid, sort of, with all that energy going through it. And so this is the most damage because when you have buildings on top of it, when that energy is moving like this, it's going to create a really strange like foundation for your building. And since it's on the surface, it's going to affect that building and cause destruction. Okay, so how we measure earthquakes. We have three different scales. We have the Mercalli scale, which just measures damage. It's kind of a subjective scale. It's not all that scientific, but here is an example. So intensity 1 Mercalli scale, it's felt by only a few people under very special circumstances, so you don't really feel this one. And it goes all the way up to 12, where there's a crazy amount of damage. You can actually see the waves on the ground move, those surface waves or L waves. And then objects are going to be thrown into the air. You're going to have a lot of devastation, a lot of deaths, a lot of destruction from this level 12 intensity on the Mercalli scale. But like I said, it's not extremely scientific. So what we use is the Richter scale. And if you've ever seen like a movie where a scientist is sitting in a room and he sees this like line of, there's a paper kind of continuously moving, and then there's something on that paper that's moving back and forth like this, and then eventually an earthquake happens and then it starts going really fast. That's what a seismograph is, a seismograph, and that's how they measure the magnitude of the energy produced from an earthquake. So they know how much energy it takes for this little thing to move. And so when it's moving very quickly and very far apart, that means that there's a high frequency wavelength and very long wavelength. So that means that there's a lot of energy coming into that system or coming out of that system. And the Richter scale is logarithmic, which means from 1 to 2, 2 is 32 times more energized than 1. So there's 32 times more energy in a 2 on the Richter scale than a 1, whereas an 8 is 32 times higher than a 7. So if you can imagine, you get to a 9, that's extremely, extremely high. There's a lot of energy in that system. The magnitude of energy is very high. And so here's the Richter scale. You know, it goes from 0 to 9. You can't see 9 down there, but essentially they use like how it feels like per kilogram of TNT. So that explosion, like dynamite, they use that as an energy monitor. So if you get to 8, it's 20 billion kilograms of dynamite, essentially, how much energy is coming out of that system. And so with an 8, we got that San Francisco earthquake in 1906. Many, many people died. The whole city itself was almost completely destroyed. It took many years to come back to the San Francisco that we see today. And there was another one in about 84, I think. There was another very large earthquake in San Francisco that caused a lot of damage as well. So then we've got the moment magnitude scale, which it's like it says, it's the moment of the earthquake happening. It describes how much energy was released at that moment that the earthquake happened. So it's kind of like the Richter scale, but it's only at that one time where the energy was released. So how we locate the epicenter, you know, where the energy hits the surface right above the focus, which the focus is the point underneath of the surface where the earthquake originates. Remember that. So how we do that is we have time differences between P and S waves because P waves are faster than S waves. We can plot those differences on a graph to determine like the distance away that this earthquake may be. And then we use a compass to encircle a station, like a seismograph station. So what we're doing is we're using this distance that we gathered from the time difference between P and S, and then we're creating a circle of that distance around the station that recorded that energy. And then we repeat that with 2 more stations, and those 3 circles meet. And where those 3 circles meet is going to be where the epicenter of that earthquake is. So here is a little map of it. Here's the graph of the time difference in minutes between P and S waves. And so this just tells you how far away from the epicenter this earthquake, or where you are. So it tells you where the station is in relation to the epicenter per 1,000 kilometers. And so then you take this data, so say you've got, you know, 4, you're at 4,000 kilometers away, and then you got that data at the Minneapolis station. So then you create a circle 4,000 miles away, and so it could be anywhere along this circle. And then you have another set of data from Detroit, and say that's 2,000 miles away. So you create this circle that's 2,000 miles all the way around, and so you're starting to get these contact points here and here. So the earthquake could be here or it could be here. And then we get one last station for triangulation. We'll say this one's 3,000 miles from this graph. So you make an area 3,000 miles away in a circle, and where all 3 of these converge is going to be where the epicenter was. So this is where the earthquake was, and all these cities felt that earthquake. So that is how you triangulate earthquakes. That is all you're going to need to know for this section in the quiz. Like always, go ahead and hit me up if you have any questions, comments, concerns, or if you want any additional information. I am always willing to support you in your scientific endeavors. So, that being said, have a great weekend, and we'll see you on the next one.